Aloha class, section 7.3, the last one of AB, but it gets a little crazy because we're looking at volumes and there's so many different types of shapes in this world. Got my mug, right? We got my mouse, right? We got my new iPhone 11. We got Homie Holmes. Homie Holmes. Oh, there goes Mitch Trubisky. He backs up. Oh, he can't even throw it 2 yards. Oh my gosh. Maybe Homie should be the quarterback for the Bears. He probably would do a little bit better. Cleo Mack not even getting it done. All right. Enough of Sunday. All right, here we go. Section 7.3. We're doing, this is the first part. Volumes of solids with known cross sections. Okay. Now there's a nice little paragraph here that you can peruse when you get a chance, but I think it's better to check out this super crazy cool website I got, okay? And what it is, well, first let me get that website going, okay? Let's check this bad boy out. Booyah. All right, so what it is we just got done, right? Class doing a section on the area between curves. Like you have the red one and the blue one, right? It would be top minus bottom as long as my rectangles wouldn't be broken up. Now what I'm going to do is I'm going to build a object on that region. Okay, so if you look at the red to the blue, I'm going to build a object on that region. Okay, and I'm going to build it with shapes, squares, equilateral triangles, and semicircles. Okay, now check out this cool website ever. Okay, I clicked squares up there, and let's say on that region I wanted to build an infinite amount of squares. Check that out, right? You get this cool, ridiculous, it's almost like a dome, like be a crazy cool dome like that you see in Australia. And if I have an infinite amount, if I have this region and I built an infinite amount of squares, I would get that crazy cool three-dimensional object. Kind of looks like my mouse, right? Kind of looks like my mouse right there. But that's what we're going to be doing here. We're going to be dealing with objects that if I were to slice it up, you would have what we call cross sections. And this would be an example of a cross section of squares. Now, I was going to go old school and take this ball, boom, boom, that you guys are having trouble with buckets. And I was going to say, hey, if you sliced a little section out of that, that's what it would look like. It'd be a circle. If I sliced it more towards the end, you would get this little itty bitty circle, right? But you know what? This website takes my demonstration to the next level. All right, check this guy out. Let's go ahead and do equilateral triangles. Check out what that bad boy would look like, right? So if you had a cross section of equilateral triangles, if you notice, the closer and closer it gets to the beginning and end, you got these really small equilateral triangles. Check out that crazy cool shape, right? Like, so architects, they get to build really cool shapes like this, and this is how they determine the type of shape that they have, right? And that would be cross sections of triangles. So it would be like a triangle, an equilateral triangle type of object, which would be really super cool if you were to ask me. Now let's look at semicircles, which ends up being a really tough problem in this section, okay? But look how cool that dude is, right? Almost looks like a slug, okay? And you can look right there that the semicircles, as you get really close, right? Just because the distance is small when you're really at the beginning or end of that region. If you're in the middle of that region, right, you get the biggest semicircle, right? Like you get one right there. Okay, so that's an example of what we're doing here. I thought that website is doing a really good job of what we're after here. Now, if you look at those cross sections we were looking at, right, you had your different shapes. And if you looked at your different shapes, we could say they all have a thickness. Now, if I took one of those shapes, okay, and let's say it was a square like this guy right here, okay, which was x by x, and how about it? It died out right now, but that's okay because I didn't write anything down, okay? Okay, got you back, booyah. Let's go ahead and get into our 7.3. How about that? At least it's writing, but of course it writes when I use the fancy finger, okay? But what we're going to do here is we're going to do exactly what we looked at that picture. Is we're going to take one of those cross sections, okay, class, we're going to find the area of one of those cross sections. That's like x times x, which is x squared. And then I'm going to multiply it by its thickness. And when I do that, guess what I get? I get the volume of this object when I go ahead and I add up an infinite amount of them. How do I get an infinite amount of them, right, class? Well, that's the idea of a limit again. And remember, that's what our integral right there is. If I have a semicircle, right, what's a semicircle? 1/2 Ooh, the radius. What the heck is the radius? Well, if that's x, then that means the radius is 1/2 of x, but it would be 1/2 r squared, right, class? That's the area of a circle, right? And then I got to do what? Drop a little pi in that guy, so it's pi r squared, but that's half of 1, so it's 1/2 pi r squared. Boom, and slap a pi on that bad boy, right? Woo, that's like 1/4. That'd be 1/8 x squared pi, right? Now that would just be the area of one of those guys, and when I multiply it by the thickness, darn, I get something like it turns into a volume. And if I have an infinite amount of those guys, I get those really cool dual shapes that we were looking at. So the volume of a solid using perpendicular cross sections is you take the integral from a to b of that region, whatever it is, you multiply it by the area of the two-dimensional slice, and you multiply it by its thickness, okay? And that's going to give us the volume of these objects. So here we go, example 3. Let's take a look at this guy. Get that off there. Example 3. The base of a solid is the region in the first quadrant. Okay, so I'm going to be talking just about the first quadrant. And it's a parabola, y equals x to the 4. So I could go 0, 0. What's that? 1, 2, 3, 4. Boom, it gets steep pretty darn quickly. And I'm only in the first quadrant, so I'm only going to draw that piece. We're at x equals 1. So there's my x equals 1, right, class? X equals 1, and the x-axis. So boom. So let's shade that region, which would be this region right here. Okay, that's the region I'm talking about. So if we go back to that problems we were doing before where I was doing those cool pictures, right, we had a region. That's the region I'm talking about. And it says that each plane is a square that's perpendicular to the x-axis. So I find it very important to draw one of those squares. And it's perpendicular to the x-axis, which means there's the base of the square. And then it's like protrudes out. Okay, so here's your job. You got to do a little bit of side work. You always want to draw off to the side your two-dimensional cross-section, which happens to be a square. Okay, and then I want you to label, how do I find the area of that cross-section? Well, it's a square, so the area of that is just side square. What is a side of that cross-section? Well, it would just be the top minus the bottom, right? So it'd be 4x squared minus 0, right? That'd be a side, and then I'm going to square it. So it'd be 4x squared, which would be 16x to the 4th. And then we're going to go back to that little formula that we had to find the volume of an object that has cross sections, right? Perpendicular cross sections. And here we're going to go from 0 to what? We're going to go from x equals 0 because this is all going to be terms of x's. Why? You know why? Because it said perpendicular to the x-axis. That means everything better be x's. So we're x equals 0 to x equals 1, right? Because we cut it off there at x equals 1. And it's going to be the area of a cross section, which is 16x to the 4th. And then we're going to multiply it by its thickness, which will give me the volume. Bang, bang, choo-choo train, right? Haven't said that bad boy in a little bit. And then I'm going to make my math easier by bringing out 16. Why? Because that is simply a constant. Go from 0 to 1 of x to the 4th dx. Check out this bad boy. That's just a power rule, right, class? So 1 over 5x to the 5th, and we're going to evaluate that from 0 to 1. Plug in those bad boys, and I get 16 over 5 units cubed. If they don't give me any units, booyah, done. Okay, how about it? Not too bad, right, class? All right, let's go to the next one. Now, if you've noticed, you've got to be very good at graphing in this section, okay? So here we go. Let's go to example 4. Uh-oh, red flag. We always mess up this semicircle guy, okay? The base of a solid in the, we're first quadrant again. We're bounded by the x-axis, the y-axis, and the line. So do me a favor. Hit that pause button. See if you can get this guy graphed on your own, okay? And then unpause it, and we'll see if we have the same answers. Okay, how do I graph that bad boy now? And there's a couple ways you could, you could solve for y. You could use intercepts. I'm going to use intercepts. If I put a 0 in there for, I think you guys probably like your slope-intercept form, so why don't I do that? Divide by that, I get negative 1/2 x plus 4. So 1, 2, 3, 4, right, class? And then I'm down 1 over 2. And then we get that little bad boy right there. I'm in the first quadrant. It's bounded by the x-axis, the y-axis, in that line. So I'm talking this region right here. It's perpendicular to the x-axis. Let's draw one of these bad boys. And it says it's a semicircle whose cross-section is solid and perpendicular. So there you go. Let's draw one of those guys. There you go, right? And the further, like if I'm right here, it's a real small. Look at, boom. Oh my gosh, sweet, right? You have all these semicircles and they get, that'd be a cool shape, huh? All right, so what did I say to do? Well, I said to do a little side work, and in your side work, you want to draw two-dimensionally the cross section. And when you draw it two-dimensionally, what I want you to do is write down how do you get the area of one of those cross sections. Well, that's a circle, right? And the area of a of a circle is pi r squared, but it's half of one. So let's go 1/2 pi r squared. Now, a lot of students make a mistake with this bad boy. Okay, so be really, really careful here. And let's think about this. Ooh, what is the radius? Well, the radius is half of the diameter, and the diameter goes from top to bottom, top to bottom, top to bottom, right? And it has to be in terms of x's. So top to bottom would be, that means this distance right here would be negative 1/2 x plus 4, right, class? That's the top minus the bottom. Oh, snap. But I have to take half of that, right? And I guess I probably should have did a better job. Let's do a better job with my snappy dap. Sorry, class, it failed on me. So here we go. I'm going to have to draw this bad boy one more time. Boom, boom. We'll take our time, though, because it is so important. I'm going to draw it here. There's one of my cross sections. So we do our little side work. Sorry if you're getting caught up. Shane, no, what the heck is that? All right, we draw one of our cross sections. That's the area is equal to 1/2 pi r squared. Okay, now you got to be careful here, okay, because boom, that's my diameter, that's my radius. I'm sure we're aware of that. Now, this distance right here would be top minus bottom, right, class? And I want it to be in terms of x's. So it'd be 1/2 x, and it was negative, right, class? Because we subtract that over plus 4 minus 0, right, which would give me that right there. Now, here we go. Now, the interesting thing about that is equal to the diameter. So the radius is 1/2 that, right, class? And this is the one thing a lot of students miss on this one. Okay, it's 1/2 of that. So there we go. So if I wanted to simplify my radius, I would get negative 1/4 x plus 2. Are we all good right there? Oh, no. What's going on? All right, so remember, what we're going to do now is we're going to go ahead and find the area of one of these cross sections, which would be 1/2 pi. What's my r? It's negative 1/4 x plus 2 squared. Ooh, got to do a lot of math on that bad boy. I did it a little bit earlier. So, it says right here, you know what? Use your calculator. So let's say this is a calculator question. If it wasn't a calculator question, you would have to simplify all that bad boy. But here we go. The volume is equal to the integral. Once again, perpendicular to the x-axis means all x's. And x is 0 here. We're going to have to find that intersection point. That would be an x-intercept to be putting a 0 in for y. So that would be 8. So we're going to go from 0 to 8 of the area, right? The area of one of your cross sections, which happens to be all of this crazy stuff. And you should kind of be able to do this by hand. So I'll talk about it times its thickness. Now, if I did have to do this by hand, you would bring that 1/2 pi out, 0 to 8, and then you'd have to practice those little FOIL skills, right, class? But if not, you can just little math 8 that bad boy. And if I did that, I got an answer of 16.755. Okay, remember, you have to truncate or round, and it'd be units cubed. Why would it be units cubed? It'd be units cubed because it is the volume, okay? Hopefully that's not too bad. Now, this lesson isn't the longest one in the world, so what I want you guys to do is when you're done, your job is to make sure you practice your worksheets right now. All right, here we go. The base of a solid is, first quadrant. We're just loving this first quadrant right here. Okay, and what I want to challenge you guys to do is hit pause and see if you can graph that bad boy. You'd be amazed how many people can't graph that. Okay, and the coordinate axes. So we're first quadrant in the coordinate axes, which means bounded by the x and the y axis. And we're squares. Okay, and the volume of the solid is given by which one of these bad boys? Okay, multiple choice question. So that means it's a parabola. The negative means it's reflected, and the 2 means up 2. So there we go. It's going to look like that. But I'm just talking about the first quadrant. So I'm just talking about that region right there. Oh, snap. Perpendicular to the y-axis. Okay. That sure changes some things, doesn't it, class? All right, let's draw one of these bad boys so I don't get confused. So the square this time, since it's perpendicular to the y-axis, is going to go right minus left. Very important to make sure you pay attention to. So I come over here and I do my side work, and I've got to be real careful about my sides right here because, right, we just said right minus left. And the area of one of those squares would be s squared. But what the heck is a side? Because it has to be in terms of y's. Why? Perpendicular to the y, and I did right minus left. So I'm going to have to solve that bad boy, right, class? So let's solve that. We have y equals 2 minus x squared. Let's subtract that 2, right? Let's divide by that negative. And then let's do a little square root. And right, what do I remember to do when I do a square root? I do that little bad boy, right? But hopefully you know that, hey, all I care about is the positive case. Why? Because I'm in that first quadrant, right? Those would be all the positive x's for that. All right, so a side is, oh, sweet, right? What am I going to do? I'm going to square that bad boy. And if I square a square root, sweet, right, I get negative y plus 2. Boom! All right, so the best thing to do, right, and they teach it some of those SAT classes, you look at the answers. No, you don't. You only look at the answers if you don't know what you're doing. So let's not look at an answer, and we're going to find the volume of this cross-section. And so it's the integral. Oh, snap! Y's, so that means it has to be y equal and y equal, which means what's the smallest y? What's the biggest y? The smallest y was 0. The highest y is I went up to 2. And then on the area of a cross-section, and the area of the cross-section is negative y plus 2, and then it's a dy, right? That's going to be my thickness. Oh, snap, please tell me it matches up with somebody. Oh, booyah, B for bears. I wish they were good. All right, that is it with the first part of volume, and that's volume of a cross-section, which means if you slice this bad boy up, you get really cool shapes. Now, I'm always going to have to tell you what type of cross-section is and which axis it's perpendicular to. Remember, if it's perpendicular to the x-axis, all x's. If it's perpendicular to the y-axis, all y's. So important to make sure you pay attention to that, okay? Aloha.